Hello, my name is David Brown. I'm the founder of the Microsoft Excel Collegiate Challenge and the author of I Do My Sudokus 20 at a Time, which was featured in the 2025 Individual Finals of the MECC Championships, happened in Las Vegas last month. All right, so let's jump in right away and see how the students did this case. So I'm going to skip over the bonus questions right now, and we'll start with level 1. But before we do, let's actually take a look at what you're doing in this case. So if I go over a couple tabs, here we can see one of the newspapers that are featured here. Here we got the Grid Gazette. It has in each of these newspapers a different Sudoku grid. Now most of you have probably done a Sudoku before. You can see here if we look at this first column, you can have numbers 1 through 9, and if we look really quickly we could see that 1, 2, 3, 4, 5, 6 is not there, but 7 and 8 are. So 6 and 9 are the values that those two cells can be. All right. And if you work through and you look at both the row, the column, the row, and then also the subpuzzle, then you could start to see, kind of eliminate what possibilities it can be. So that's what we're going to do here. Is we're going to be solving Sudokus. The first challenge, though, is that we have 20 different newspapers to deal with. All right, and each one has Sudokus at different points in the spreadsheet. So you're going to have to be able to figure out where it is and pull that data back in to make that usable. All right, so to do that, we're going to start out on level 1 by just getting the name of the puzzle. All right, and it tells us here the names are either in B7, K7, T7, B23, K23, or T23. So they're not just in a random location, which would make this quite a bit more challenging, but we have some structure around it. So for this first one, we have kickoff grid. We can see that's the correct answer. What I'm going to do is I'm just going to go to the tab in 0 and click on where that answer is. All right, it's up there in K23. We hit enter. We see our answer is not correct. Well, the reason for that is we haven't taken off the dash easy at the end. So let's actually take care of that real quick. We're going to use a text before, and our delimiter here is going to be a space with that dash. All right, let's try that. It doesn't work. Why is that? Well, if we come back over here and we look at what kind of dash it is, that's not the same kind of dash I just used. So what I'm going to do is I'm going to copy it, and then we're going to go put it back in our formula. This is where it can be very particular how you put one of these things in. So we want a space and then the dash. So now let's hit enter, and now we see it's okay. So we're going to make sure we get that right dash and then get kickoff grid there. Now this formula is not great because if I copy it down, you see it doesn't work anymore, right? And importantly, this is not dynamic, right? It's not taking in K23 and N0 as inputs. So now we're going to have to go and replace what we have here and make that more dynamic. So how can we do that? Well, first, we're going to use the indirect function. All right, so I'm going to put an indirect around our cell reference. I'm going to put it in quotes because that's what's required for the indirect function, and we still have the right answer. Now, importantly, it being in quotes means it's a string variable, so now we can manipulate it. And so what I'm going to do here is I'm going to replace the N0 text with a reference to the cell, to the information that's in cell H51 in this case. So we put that there, we put our ampersand on it, there we go, and we still have our formula working. Now if we copy this down, we see it's not going to work most of the time, but it works sometimes. Now why is it working sometimes? Because it's working whenever K23 is the location. If K23 is not the location, it's not working because we still have the K23 hard-coded. So let's also replace that. So I'm going to come and delete the K23 and put my ampersand on there to now attach the K23. We don't need that last quote at the end. And now we have a fully dynamic function that we can copy down, and we see we get all of our answers correct. All right, so here the key function is this indirect function. It can be a tricky one to learn. I'm not going to go deep into depth in it, but that's the basic idea. It allows you to pull something from somewhere else in the spreadsheet, often another tab, by using references to the location there. All right, moving on. So once we know what puzzles, we can pull data from the different puzzles. Now we got to pull a particular cell contents. So in this case, we want to know what cell R1C9 holds. So row 1, column 9 of the puzzle on newspaper in 0, right? That's going to be one of our tabs down here. Now, if we can pull that back, we can see that the number is 6. So let's just go look real quick. So row 1 column 6, or sorry, let's go back. Row 1, column 9, make sure we get it right. Row 1, column, so row 1, there it is. Column 9 is that value of 6. So that's what we want to pull back, but we want to do it with a formula, not having to look these things up manually. All right, so how are we going to do that? Well, let's start out by pulling back all the data from that case. So I'm going to use, let's just first reference the top left cell. It's the value of 2. Now I want to use indirect again to pull that back. So let's use an indirect function. We're going to turn our spreadsheet name into a string variable. Now we still got it working. Notice this is crossed out here. It just means it needs to recalculate in Excel. It'll eventually recalculate, not a big deal, so we'll just go with that. And let's get rid of our N0. We'll just reference our cell. Make sure we're still working, so I did not put my ampersand in there to connect them. All right, you could use the CONCAT function here. I'm just going to use the ampersand. And so we have that. And the last thing we replace is that K25. Now on the first level, we had K25 given to us, or K23 in this case, where the data was. We don't have that here anymore. So because we don't have that data here anymore, we're going to have to look it up. All right, so this K25, let's actually make this now a XLOOKUP of, we got to find N0, it's our data we're working with, and all of this data, all of this lookup data, lock that, and then put it back into here. All right, so that's what we want to call back. Let's see if we get. Oh, we didn't close our quote there. That's what it is. All right, so there we got it. But we got kickoff grid easy and not the value of 2. So what are we getting? Well, again, we're getting K23, not K25. Now here's where we can actually use a little bit of a trick, because we're not going to just want to pull back the 2, we want to pull back this whole grid. So our last step here is to use the offset function. So what the offset function is going to do, and we'll start with the basics, is we pick our starting cell, our reference cell. That's what the indirect just gave us. And now we tell it how many rows to go down and how many columns to go to the right. If you want to go up or to the left, you can use negatives. In this case, I want to go down 2 rows, so I'm going to put a 2 in. And I don't want to go any rows to the right, so I'll get a 0. And that gives us the value of 2. So basically, offset just takes some reference cell, and you can move relative to that reference. Now the last piece I want to do is I want not just one cell, but I want an array that's 9 cells tall by 9 cells wide. So 9 rows, 9 columns. And now I just brought back the entire array of data. All right, that's what I'm looking to do, and make that relatively easy. Now, one important thing I'm going to do right now is recognize that this is a big function that I don't want to have to write again. And I know I'm going to have to get the data from these puzzles a lot throughout the problem. So let's go ahead and make this a lambda. All right, so what I'm going to do is I'm going to copy this formula. And I'm going to come down here and I'm going to do lambda. The input is ultimately going to be the tab that I'm interested in. And the formula I'm going to use is to go from the given tab, right, which was N0 before, and then look it up in that array to get all the other data back. Now to give my lambda function the data, now I have to put it in parentheses here at the end. So notice this is an odd syntax here, but it's one that we're going to have to use whenever we're working with lambdas. So it's one that's worth learning how it works. All right, and you can see that now I'm just getting the exact same thing as before. I've just done it in the lambda. Now why this is important is the next step. I can now copy this function. All right, notice I'm just copying the function. I'm going to go to my name manager now, and I'm going to make a new name. So I'm going to call this getPuzzle. I'm going to paste in my lambda. I'm going to close that. And now what I can do is I can just say getPuzzle, refer to the tab N0, and now I have that exact same thing. All right, so it's allowed me to have a very simple function to do a complicated thing and get that data back. All right, so I have my whole puzzle here. Now let's actually see what the question asks. It says, give us what's in R1C9. All right, so now I can do an index over this. So let's do an index over this whole thing. I want to get row 1, column 9. All right, that's how the index function is going to work, 1 and 9. And I get the value of 6, which is going to match my answer up here. So I look good there, but I still haven't used this input as a parameter. So what I want to do as the last step is I'm just going to use the mid function to take that text. I want the second character and I want one character. That'll get me my row. If I want my column, I could do the same thing. Reference that H91. Now I want the fourth character to start from, and I want one character back. And now I have a nice dynamic formula that I should be able to use across the entire level. All right, we see it still works for the base case. If I copy it down, we've got all our answers correct. Now in this case, if I want to get what's in a given cell, I could also make this a lambda. Right? What I need to give it is the puzzle, the row, and the column. Right? That's what I just did in this function. Since that doesn't give me a whole lot, I'm not necessarily going to build that one up. It's not as complicated. I don't think I need to build it. You know, sometimes you can change your mind and you can go back and build it later. But we'll see a lot of this lambda building happening throughout this walkthrough. All right, the next level. So now what we're going to start doing is getting all the numbers in a given row, in a given column, in a given subpuzzle. Because that's eventually going to get us to the point where we can know what numbers it can't be. That way we can determine what numbers a given cell could be. Right? And if we can figure out if that's just a unique single number, then we can fill that number in. That's kind of our solution strategy for solving a Sudoku. So now what we're going to do is, given a newspaper and a column, in this case column 1, let's pull back all 9 numbers from that column, or at least all 9 cells and what's in them, oftentimes not all 9 numbers, and then we'll add them up together. All right, so let's build that up. So the first thing, let's do our get puzzle. All right, so we do our get puzzle. We got all our data. Now we want to get a given column. So I can again use my index function. Right? And if I want one column, that means I want all the rows. So if I want all the rows, I can use my sequence function for 1 through 9. And now which row do I want? Well, let's do mid of my row. Yeah, let's do mid of that value. I want the second value, and I want one character. Now we can see I have that row. Now if I wanted to, I can go ahead and sum that up. So let's sum up that entire column, and I get the value of 30. All right, so I've got my answer there. If I take this function, copy it over, so again, put that in there, and let's make sure it works for other things. Copy it, paste, and we copy down. All right, so we got all our answers pretty quickly there. Here I do want to stop and make a couple lambdas. One, I'm going to make this same function we just made before we did the sum. I want to put that into a lambda. And I want to do the same thing for columns. And the reason is that I know I'm going to be pulling the row and the column information quite a bit. So let's do that. All right, so let's take this before I did the sum, so same function. Let's come down here and just do my equals. All right, there we got it. So now I'm going to do a lambda where I'm going to first say the first argument's going to be the puzzle, and the second argument is going to be, in this case, we want the column number. So I'll just call that call. So I have 2 variables. So now when I run this, the index, I just replace it with the variable puzzle. Right? That's what's going to be coming in from the user. My sequence 9 doesn't need to change. And here, I just need the column number. All right? So there's going to be a nice generic function that gives me back that whole column of data. Now again, to feed a lambda, right, this is the formula. It'll work just fine, but it needs to know what puzzle and column is. So that's what we do is we put at the end here. So the puzzle, well, let's get puzzle again on our newspaper tab. And then for the column, here I have to take my data. Let's get the second row and get one character. And now I have that same data I had before. It's just in the context of a lambda, which again, now I can copy. Go to my name manager, create a new lambda. We'll call this get column, paste my formula in, and we're set there. Now I want to do the same thing just with a row. So let's back this up. Let's call this, instead of column, let's call it row. And now I simply want to flip my sequence 9. That'll represent the columns. So now I want row there. And now I have the same thing working. It's just giving me the first row instead of the first column. And now we can call this just the same way as we did before. Let's come into the name manager, new. We'll call this get row, paste in, and say OK. All right, so now we got the row and the column. And again, we might have done this in a level where we had the row, but because they're so similar, that's why I didn't design it to have a separate level for the row. What I did design was the next level, level 4, gets trickier because now we have to pull back a 3x3 grid of the subpuzzle. All right, so let's look at how we're going to do that. So get puzzle, we'll start within 0 again, and now we've got our data. So we're going to come a little further, and now we can see which row we want. So let's just do a mid of our value, comma 2, comma 1. So we want row 7, and then I want column 9. All right, so we can know that that's going to put me in this subpuzzle right here. All right, row 7, column 9. And so what you can see is we want some way to identify it's in this grid, not in this subpuzzle, excuse me, or this subpuzzle, right? And so the way I'm going to think about this is going to the bottom right corner of each of my subpuzzles. And you'll see why I'm going to do that in a second. And so to make that happen, what I'm going to do is a calculation here where I'm going to do a round up of that value divided by 3, round to the nearest integer. And you'll see that gets me a value of 3. If I then multiply those by 3, it gets my position within the puzzle. So it takes the 7 to a 9 and the 9 to a 9. If instead I just hacked this up and made this a 2 and a 4, right, then it's going to take me to the 3rd row, 6th column. So let's just check that. So if you're in row 2, column 4, right, you want to be in this subpuzzle right here, which is row 3, column 6. All right, so it's taking you to that bottom corner of that grid. All right, let's put our values back so we can see where I'm going. Now, why am I doing that? Well, it's because I want to take this array and get a subset of it. And what I can do to do that is use the take function. All right, so I'm going to take first this whole array and only include 9 rows and 9 columns, right, which happens to be the entire thing, right? Because when you're using the take function, you can take, starting from the top corner and going this way, right, you can pick how many rows and how many columns to do, or from the bottom corner, you can come back this way. So my strategy here is going to be to first pick the most I could use, right? So if we ended up in just this first one, we would take 3 rows, 6 columns, and then I'm going to come from the back end and take only 3 by 3 back. All right, so here I got 9 by 9, and if I want to do that same thing again, I'm going to do another take of that array, and now I'm going to use -3, -3. So now you can see I've gotten the bottom corner here, 0, 4, 7, 9. That's what I pulled back. If instead our earlier example of 2 and 4, right, now we see that we've pulled that 3 by 3 grid back. And again, that's by doing this take, where I'm first cutting off how big it is this direction, and then I'm cutting back from there to the 3 by 3 space. All right, now the last step is to, like the others, add all this up. I'd like to get it in a nice, easy way to work with, kind of the same shape as the other ones. So let's just do a 2-column on that. And essentially now I have my get subpuzzle built up here. So let's take this and build this into a lambda. All right, so to build this into a lambda, I'm going to kind of take the hardest part of this function, which is this piece right here, and I'll start building my lambda from there. So we're going to try to get this same column here with a lambda. What we're going to need our puzzle, our row, and our column, just like before. And now I'm going to write our function. So we had our take. What we referred to were these two values. So this now instead is going to have to be, well, this first one is our puzzle. So let's go ahead and just reference puzzle. Now, the row that we need, in this case, we took whatever row was input from the user. If you remember, we rounded that up. So row divided by 3, round to 0, times 3. All right, that was the trick we did. Let's take that same thing and replace the column. All right, so now we need our call to go there. So that's going to get our 2 takes done. All right. We also wanted to do a to call on that, so let's put that on, and then close our lambda. but we also have to give it the information we need. So again, we need to do our get puzzle on our data, and then we need to do our same mid trick that we've been doing. Comma 1 and mid of that same thing, comma 4, comma 1. And occasionally you're going to miss something. There, I missed it at the end of the get puzzle. There we go. So we should have the same data back. Well, we don't. Why is that? Well, it's because I changed the data here. Right? If these actually are built to match 7 and 9, now we match again. So this one's not going to work because I broke the links back to the data. This one is going to work. All right, so we got our lambda to get our columns. So let's go ahead and, again, build another lambda here. So name manager, get subpuzzle, and paste. All right, so now what does the question actually ask us to do? It asks us to add up the subpuzzle again. So let's just do a sum of get subpuzzle from that, and we got to give it the mid of this, comma 2, comma 1, comma mid of that. Again, watch your parentheses. That, comma 4, comma 1. Again, I forgot to close that subpuzzle back there. We get a value error. So occasionally, Sum doesn't like to play nice with arrays that are vertical. So I'm going to try to transpose it and move it around a little bit. Let's see. Oh, I said get subpuzzle, but I didn't tell it to get the puzzle. There we go. We got a get puzzle there. And that was my error. So let's actually see if we needed that transpose. A lot of times we don't. There we go. Sometimes arrays can be finicky, but in this case, it was just that I didn't type my get puzzle lambda in there. All right. So there we've gotten through level 4. We've got a lot of the machinery set up to help us build level 5, 6, and 7, which are going to be the tricky ones. And so let's jump into that. All right, so for this one, I want to organize all my data. I want my row, column, and subpuzzle. And I pull that all in to start. So I'm going to use my get row, newspaper, mid of that, comma 2, comma 1. But you guys are getting tired of doing mids at this point. And I forgot to get my puzzle again. So let's get our puzzle. We have to get that array in there. Oh, and I just need a row. So I gave it too much. Didn't need the column there. So let's take that. Let's just pop it over here. Pop that here. I'm just going to make the work of some of my typing already. So we'll do get column. Change that to a 4 there. There we go. And then we need to get subpuzzle. And here we need both of them. Let's change one to a 4 there. All right, so now we have all of our data. I'm going to center that up so it's a little easier to see what everything is. And so now we can kind of visually look and eliminate and see what numbers we don't have, right? To kind of make sure we know what we're going to be doing. We have a 5, 3, 4, 1, and 8. We add a 4 here, but we already have it. Here we add a 7 and a 5. We already had and a 2. All right, so it looks like 6 and 9 are the only things we don't have. So that's what we're looking for. That's the answer over here. Now, how are we going to functionally do that? Well, let's start building out our answer. So the strategy here is I know that the numbers 1 through 9 are potential targets. And what I can do is I can do a XMATCH on all of that data, and I can do it in each of these rows of what we already have. So what you can see here is if I find the number, right, I found a 1 in the 8th position of this row, so that's why I got an XMATCH 8. If I get an error, though, that means it didn't find it, so it's missing. So if I run an if error on my XMATCH, all right, if error, so let's just give it a blank if it's an error, then I have blanks where it's not something, where it's not looking up the value properly. And actually, rather than if error, I just want to use is error, because I don't really need to know a different value. I just want to know if it's an error or not. So let's do is error instead of if error, and now we see which ones are true. And now the idea is if I lock what I'm looking for and copy this over, now we can see what's false and true across all of these. All right, so we're checking for the row, the column, and the subpuzzle. Now if we multiply these together, all right, so this is a logical test where we're multiplying each of these pieces, each of these arrays together, so only if they're all true will it still be true. And here it also transforms it to a number, and we can see we have two values that are true, the 1 and the 1. All right, so our very last step here then is to say, okay, well, we know of the numbers 1 through 9, only 2 of them, the ones with 1s, are the ones we want, and so we can do a filter to filter this array only on cases where 1s occur, or where it's true. So 1 is equal to true, 0 is false, and so we have an array with 6 and 9. So that's ultimately how we're going to get this intersection here to know what numbers could be there. All right, so let's actually build this one more time into a lambda. So the trickiest part is probably this is error match. So let's go ahead and take that. I'm going to copy it. All right, and I'm going to build this all together. So let's do equals lambda. We know we want our puzzle, our row, and our column. And then our calculation here is going to be our filter. What are we going to filter? Well, just a sequence of 9 numbers. And we're going to do it if it's true that if error is error of the XMATCH is true. All right, if it's actually an error. But I don't want to use any of these arrays, so let's actually just replace those. So I want sequence 9 right there. And then for the row array, this is where I use my get row lambda. Right, so I got my puzzle, and I got my row. Now, if I want to do this with more than one argument, notice how I multiplied them together before. I have to surround them by parentheses, and then multiply them together. So I'm going to take this whole thing here, and I'm going to multiply that by itself and by itself. All right, so now all 3 conditions have to be true for the filter to work. But in this case, I don't want to always just use get row. I want to use get col, and I want to use my column instead. And I want to use get subpuzzle. You can hopefully see why it's so valuable to build out those helper functions or those lambdas along the way. All right, so we got our filter coming through. I need to close my filter finally and on my lambda. But I got to give it the data at the end, so let's do our get puzzle. We got to pull that in. We got to also pull in our row, so mid of that, comma 3, comma 2, comma 1, right? Comma mid of H206, comma 4, comma 1. Make sure I get my parentheses lined up. And somewhere in here I have an error, all right? Not all that surprising given how much is going on here. I tried to be careful in building it, and I'm guessing it's back here in this initial piece of when I built the first one. So let's see if I can find it real quick. So that's all contained. Oh, it's giving me a name error. So let's see here. So it's going to give me a name error because it's in a lambda. It's not going to, because it is a lambda, it's not going to give me that auto information back real quick. Is there matched? And then we have the purple closes there. And then my filter closes after that, and then my lambda. I think I just have one extra parentheses. Yep, and that was our situation. So one extra parentheses we had to take out, and now we have our lambda built. So let's one more time go and put this in a lambda. Actually, we'll probably do this more than one more time. So let's say get possible values is this one. We say OK, we close it, and let's go over and answer these to make sure we're working. So let's do equals get possible values with get puzzle of that. Then we have our mid of our value, comma 2, comma 1. Mid of that, comma 4, comma 1. Enter. Not the right answer because it's spilling down. So what do we want to do? We want to do a quick text join. This is the easy piece on this one. And we join together all the possible values. So we got to skip the things that are missing. So let's see here. What did I do wrong? All right, so we had a little bit of a problem there with our lambda. I'm not exactly sure what is causing it. A lot of times Excel just kind of has these little hiccups here and there. And so here I'm going to show you a workaround. So instead of using the get possible values lambda here, what we're going to do is we're going to go to the name manager, go to our lambda, and we're just going to copy the whole thing. All right. We're going to come out and we're just going to replace get possible values with the actual lambda. All right, so we have the lambda in here. So now instead of just using the name manager, it's actually going directly to the lambda, and now we get the correct answer. Why was that happening? I'm not exactly sure. All right, so we copy that there, copy it down, and we are all set on level 5. Now on level 6, what we're going to try to do is figure out all the different cell locations that have only one possible value and add up those possible values. So in level 5, we figured out which possible values there could be. Now we need to look over the entire Sudoku puzzle, right? And I actually did some pre-setup here where I'm pulling the puzzle in. Figure out which of these cells aren't already full, and of the ones that are zeros, notice Excel is filling a 0 for a blank here. For any of those zeros, we want to figure out if there's only one possible value, what is that value? All right, so I've done a little extra setup here I'm going to talk you through. I got all my game numbers over here. I'm actually going to condense all this a little bit just to make it a little easier to work with. We got all of our game numbers, and so I'm going to build this for a data table. I'm going to show you that in a second, but I've also set it up here to where I have a control cell, and I'll show it to you. It's just looking up the game number and giving me back the newspaper. So for example, if I change this to game 102, we now update to puzzle into, and my board is going to update here as well. All right, that's going to be really important when we're actually running this data table, and I'll show you again how that works once we have our answer. All right, so we have our board. I'm going to basically recreate it off to the right here, but I only want to do so as long as this number, right, is not greater than 0. So if it's greater than 0, just give me a blank. All right, so if it is 0, then the first thing I want to do is see whether I have a unique value for my lambda there. What I had from the last level. So let's go ahead and count, and I'm just going to say lambda value right now, and you'll see where I'm going in a second. And I'm going to do another if here. So if the count of the lambda value is equal to 1, then give me that lambda value. All right, so in the case that we have a situation where there's only one possible answer, that's what I want to see. If that's not the case, well, again, just give me a blank. So I'm going to be getting blanks most of the time here, but occasionally I'm going to go ahead and get something back, that value that I need. Now, I set this up with the word lambda value because I want to layer on a let here. All right, so I'm going to say at the beginning, let lambda value, and I'm going to make it equal to 1 right now. All right, we're going to replace that in a second. This is the basic structure. So if that's 0, fill in a 1, and let's see how that works. All right, so I got a 9 by 9 here, and basically now all I've done is I've captured all the cells that have zeros over here, right? Because the lambda value is always 1. But that's not exactly what I want, right? What I want, and here let's go ahead and I'm gonna again build a little structure here. What I want is it to fill in based, and let's make this all centered. We're making it look nice now, so it's a little easier to work with. All right, now I want it to be based on the row and column from the puzzle instead. So we need to use that lambda we had. Again, it'd be nice to actually just use the name manager. That's not working for me right now. So again, we're just going to use our hack here, and I'm going to take the whole lambda call I had over here. We're going to copy that and move it down here. This is another reason why I'm using the let, because I only have to have this lambda in here once. All right, so let's pull my lambda in. It has my get puzzle, but here I don't want to do the get puzzle from what it was the previous time. I want to do my get puzzle off of my game data table, and then which row and column I want. I don't need to do the mid tricks anymore. All right, here I can base it off the row that I'm in. All right, and make sure we're going to lock the row, and then the column I'm in, and lock that as well. All right, so now I'm pulling based on 1, 1 in this puzzle. I still have a blank because I already have a value over here in the 2. And before I drag this, let's make sure I go ahead and lock where my puzzle is. Now we can drag across, and we see that one of those turned to the value 3. If we drag it down, we have a lot more filling in. So now we're only filling in the cells that we know what the value can be, because there's only one possible value there. Now the answer to the level then is what is the sum of all those. So let's come back, sum them all up, and we get the value 41. All right, so now the last step for this level then is to capture that answer. So we're going to set our answer up here equal to 41, and now I'm going to build a data table. So Alt-AWT takes me to the data menu, if you see up here, the what if analysis, and the T gives me data table. And what I want to change here is the column input. So the column input is going into this control cell. Remember when I changed that, it changes the puzzle number. And now what it's going to do is essentially give me all the different answers for taking all these values in the column, plugging them into this top control cell, and then giving me all the different answers back. It's basically just handling a bunch of copy-paste on the inputs back and forth to do a bunch of scenarios, or again, kind of a what-if analysis. All right, we run that. In this case, it hasn't updated, so I'm going to hit F9. F9 updates all the values, and now let's check to see if those are correct. We'll just link them over to our answers, and we have level 6 correct. All right, now going to level 7, now we just got to solve the puzzle. Now the way we're going to think about doing that is iteratively, the same way we did the last level. We're going to basically start with our puzzle. We're going to then solve for the values that are uniquely determined. And then we're going to rebuild our puzzle. That's why I've kind of set up the grid here to be built like a Sudoku puzzle already. To take this puzzle, update it with our new values, and get the new puzzle. We can then take the new puzzle and then apply this same logic to it to just iterate over and over. So we're basically going to copy this thing over to the right once we get our structure established. I've also set this up ahead of time with the same game data table. So let's just go ahead and take our work from the last level and move it on down. We got to make sure everything translates, so we're going to be pretty careful here, right? Because notice my references here are not moving, so let's go ahead and make sure that those move. So we're going to change those top corner references. So I want to use this puzzle, right? That way it works with level 7. And I also want to base this not on row 248. Let's make that 289. All right, now let's make sure we got everything working. We're going to replace things, move it across and down. All right, and now we want to build our puzzle out. So here I'm just going to do a very simple if statement. So if I've got a number in the cell that I know is the new value, well, let's take that one. Otherwise, let's take the value that I used to have in the original puzzle. All right, so we copy that. Whoop, we can't go all the way across like that. I'm going to paste my formulas so I keep my formatting looking good here. And now I have that second puzzle that I need. So essentially you can think of this is the starting puzzle. This is now a new starting puzzle that we can use to apply the same logic to. So let's copy this all over. And let's move it right over here. All right, now we still have to repoint our references, right, to make sure everything's working okay. So now we've got a new puzzle to work with. Now what puzzle do we have? Well, we can't use our get puzzle anymore, but we have a direct puzzle that we can reference. So let's go ahead and fix that. So now instead of referencing that, we can get this entire puzzle. All right, that's what that get puzzle lambda was doing. We're referencing our row reference here. Let's just pull that over. And let's copy this over and down and make sure it looks like it's working. All right, we've got a new cell here, 8. We can just look to make sure it makes sense. There's no 8 there, no 8 there. We can really see right there that this is going to be determined and should be an 8. And we've got it. All right, so that all looks good. Now, to do that, we had to do some copy pasting, and we have to, again, build this again. Again, this is going to be based on its references. And so to do this, the easiest way to do it is not to just copy this thing and redo it every time, because we have to move some of the cell references. But instead what we can do is we can get rid of those absolute cell references. Right? When I built these formulas, I had to be referencing this puzzle absolutely. But now that I've dragged it over and across, I don't need the dollar signs anymore. So what I'm going to do is I'm going to come in here, Control H, I'm going to find any dollar signs, and I'm going to replace them with nothing. So let's replace all. I got rid of all my dollar signs, but I haven't really changed any of the underlying formulas. And why that's important is as soon as I copy this over, now everything is going to relatively refer to where it was before. And now I'm updating, and every time I copy paste this, I create a new version of the puzzle and a new version of the answers. And I can keep going out further until I am no longer solving any more, and I've gotten the puzzle entirely solved. All right, and I'm going to go just a couple more to make sure I have enough room and have enough answers. All right, so that's going to do all the puzzle solving for us. We can actually see that these were the last 3 cells solved, because as soon as we get here, we see there are no more zeros left and we've fully solved the puzzle. Now, to answer the question, well, the question says multiply the solves per turn times one another to get our final value. So let's just do a little bit more work here. So how are we going to do that? I'm just going to do a count. We can just do a count since we don't have other values here of everything there. And I do want to handle the case if it happens to be 0. So we're going to say so we're going to do the minimum of that count and 1. And the reason is we're going to multiply all these together. And if you multiply something by 1, you don't change its value. So that'll work for us. So we want the max of that, or 1. All right, so we have 8 for that value. Let's go to our next puzzle. We have a 9. We have a 10. And this is a little bit manual. I could have done this before I copied everything over, and it would have been a little quicker. But let's just make sure we get everything done nicely here. We want to make sure we get at least to where we solved this puzzle, right? We got past that point, and we got all our extra area. So now let's come back to the beginning. We're going to do a product and just multiply that all together until we get to the end. We have our 1520, and just like last time, we're going to build our data table. Alt AWT, using our column input cell and our control cell. I'm going to set my answers equal over here. And notice how everything's going to be wrong. Right, I haven't updated my values yet. Sometimes you have to hit F9. That's going to make sure all those calculate. So F9 happens. All right, so I didn't get all the answers correct there. Probably have a bug somewhere. One way to test that is let's just put 121 here. And we can see this exact situation and where the problem is. And I actually looked at this a little bit to make sure I could find it. But the issue is actually I had an extra column inserted here. I wasn't careful in my copying, and so now I was referencing the wrong values going forward. So let's go ahead and delete this work. It didn't happen to matter for that first one, but it did matter afterwards. So now we can copy what we had. Make sure we really get it in the right spot now. There we go. So we have to be extra careful in doing this. Otherwise you run into the error I just did. So you can see where time pressure and all sorts of other things can make this really tough for competitors to do on a live basis. So let's come back, put these last couple back in. Make sure everything's pointing at the right spot. We'll have to recalculate everything in a second. There it's going. All right, now it looks like it's fully solved. Let's go back to our answer. Looks okay. Let's rerun our data table now. And now we see that everything's correct. So we've gotten through all 7 levels. Okay, not all right correct. 1 is off still. Let's go look at that one. And I suspect this one is probably because we didn't have enough space copied out here. You never know exactly how far you're going to go. And in this case, you can actually see, yeah, we have more zeros here. If we just kind of look at that visually, we have more than 5 zeros. So I think we just need one more iteration of this. Let's see if that'll do it. So we'll actually copy 2 to make sure we end up with nothing left. All right, we see we fully solved it. By the end, we just didn't go far enough. So let's remember first we got to go all the way to FZ. So let's rebuild our product function out here. So instead of going to FG, let's make it FZ. Let's one more time F9 our data table. And now we see we got them all right. Definitely a few pitfalls in there. You don't really know how far you're going to have to go to solve these Sudokus in this case. And so a little bit of guessing and checking kind of helped us get there. But the basic idea, again, is that we can build our formulas kind of step by step throughout this case to where we have one big lambda built, which is really a massively complex formula. But if we know a few Excel techniques, we're able to use them to apply that big formula in a small usable context and really do something very impressive, solving 20 Sudokus at one time, and really flex our Excel skills in the process. All right, so our very last step, is to go do those bonus questions. So we have a few bonus questions I want to go over. We changed our formatting a little bit, so let's give us some room to kind of see what these all are and make sure they fit on this page. We're just going to go through each bonus question and make sure we can get these as well. All right, so number 1 is basically that we're going to try to take the labels on each puzzle. Right? If we come look at this one's labeled as easy. And we're going to take all of those and then figure out are they easy, medium, or hard, and attribute 5 points to easy, 7 to medium, and 11 points to hard. All right, so we're going to come down here. The first thing is level 1 basically asks us to get the name, so it was before the dash. Well, now let's take that same formula. So move it over here. And we're going to get the same thing after the dash. So let's just go with after. All right, we're going to copy that down. Notice how I'm getting the strike through on all these values. That means that they're not necessarily calculated. And that's not always true in Excel. You can see it's actually calculating these values as we go through, so they're not really stale values. It's because we have those data tables that I created earlier that are throwing this off. But really, it's not going to impair us too much, so let's just go ahead and work with it. We're also going to have easy, medium, and hard. Let's just actually copy those. And we're just going to attribute values to them, so 5, 7, and 11. And now what we can do is we can just sum up an XLOOKUP of these. So let's sum an XLOOKUP of all of these values. In that column is where we want to find that, and then we got our point values. And so what I'm doing here is essentially doing 20 XLOOKUPs at the same time. That's why I have this big range at the start of my XLOOKUP. And then I'm adding them all together within this formula. And that's where we get the value 123. We can paste that. And we don't have the right answer. And we didn't get the right answer because we didn't have the first one in here. See, actually, I shifted by 1 when I pasted that, so let's just go ahead and get the bottom one. Rebuild our formula to drag down by 1. And there we've got our right answer. All right, moving forward, let's go ahead and I'm going to actually add a new tab here. We'll call this bonus 2 because I need some room to work. Because this next one is asking which author is most prolific, so we've got to pull in the author names across all 20 tabs. So to do that, I need just a little bit of help here, so I'm going to get some helper cells. All right, so we know we need the tab numbers, and I also need the cells where this is happening. So we know that the titles are in, for example, B7, K7, T7. So let me copy this over. But also note that the author is always right below the title. All right, so we're going to keep an eye on that. So what we need to do is just create all the different options for this. So we know we got, I'm just going to take this format. So we'll have B2, B8 instead of 7. So B, K, and T, K8, T8. And if you go look, the others are 19, so B19, K19, T19. Now what I want to do is pull back the value in these cells. Well, we already did that over here using our indirect function. So let's go ahead and just copy our indirect. And here I just got to re-reference to the tab and to the cell I want. All right, and let's just make sure we lock that. So that's locking the row, that's locking the column. And you see a lot of times this is not giving us what we want. All right, so we have the fill the 9x9 grid, but here we have a by in grid. All right, so that's what we're going to work with. We're going to try to look at the authors instead of the fill number. So first, let's go ahead and put this all in one big column of data to work with. Now we can see it a little bit better. But now I want to know what are the unique values, right? Because we want to know which one shows up the most. So now we have all the values. So now we can do a COUNTIF on that whole range on all my unique values. So I get all of my counts. I can see that a blank shows up 49 times. That's not super helpful for us. We also see fill the grid shows up 11 times. Again, not super helpful for us. So instead, let's go ahead and sort this. We can exclude those two, but I want to sort by the second column. We'll sort it ascending. And we can see if we go to the bottom here, there's our first author. So Chris Webb would be our answer. Now, if you want to strip it out, you got to take off the MVP at the end and the by at the beginning, but we can just take Chris Webb, paste it in, and we've got our answer. All right. Now bonus 3. What's the product of the number of upper and lowercase letters between the two designations? All right, so first thing is we got to get the puzzle names. So we have our puzzle names right here. We can see when we have, some uppercase, some lowercase letters, and we'll have to sort out how many of each we have. So what I'm going to do here is I'm going to create another tab again. So Shift F11 for another tab. Let's call this bonus 3. I was using Alt-H-O-R to rename the tab. And I want to get all these case titles, so I'm just going to concatenate them all together over here to work with them. So let's go CONCAT of all that data. So we got all our titles already. All right, and so we've got a bunch of letters all sorted out there. Now what I want to do is split them into individual characters. So here's where I can use a sequence on, so I can use the mid function with the sequence. We've done this enough times already, so we're going to take that text. We're going to do a sequence on the length of that. We get 1, and now we split out all the characters. We can see we're going down 347 lines, so we got a lot of lines to work with. We don't want to individually classify these. So what I'm going to do is I'm going to try to find the lowercase letters and the uppercase letters. So we're going to say first, if, and now we're going to do this little trick here. We're going to say if that is less than or equal to Z. Sorry, I messed it up. So if that's less than or equal to capital Z, and so I'm going to multiply it together. and it is greater than or equal to A. Let's give me a 1, otherwise give me a 0. All right, so we get a 1. Now if I do that same function again, but we're going to make it lowercase z and lowercase a, it'll just do lowercase letters. All right, so I thought that would have worked. I know the first one is working. It's not working with the lowercase. So what we're going to have to do instead is wrap each of these with the code function. So it's a small change, but the code function takes a letter value and switches it into a numeric value. And this is just doing what sometimes Excel is smart enough to do on its own and passing it through. So we're going to do that same thing. We get the same answer there. We copy it over, we see we get a 0, so that's good. But let's flip these to lowercase in this case. And now if we copy that down, I think we're going to be okay. All right, so this one, oh, I didn't get my references right, so let's just get our B in here and B. Forgot to lock those, so let's try that one more time. There we go. Now we can see our lowercase letters are giving us 1s, our uppercases are giving us 1s here. So now we should be able to just sum the columns. 65 and 244. Multiply those together. Get our answer. And we see it is correct. All right. So that was, again, just kind of a nice trick of using code, which takes a number and turns it a letter and turns it into a code. You can also use the char function to go from a letter to the character, and in this case doing those ranges. It was smart enough to do it just with A and Z, but I think that's a generic non-case sensitive version, which I didn't realize there. All right, moving on. What's the sum of all the provided numbers in all 20 Sudoku puzzles? So this is actually really similar to what we did here, right? We need to pull in a given cell from the puzzle. The difference is we need to be a couple cells shifted off, and we need to get all the values instead. So if we take this, really it's the indirect that we want. All right, so let's copy that. I'm going to put it in the cell next to the one I'm actually working with. All right, that gives me the title. But what I want to do is I want to move away from it. So I'm going to use the offset like we talked about before. Move 2 rows down and no columns. That gives me my first number. If I want all the numbers, again, we do the 9-9 trick we did earlier. It's going to spill, but we can sum it. And now we take that whole array, sum it together, we get 207. If we copy that all down and then get our max, we are very quickly to our answer there. And if we read carefully, we know we're not supposed to max it, we're supposed to sum it. And there we get our answer correct. All right, last bonus questions. What's the score of the newspaper with the highest scoring name? Names are scored based on the letter value. So A is 1, B is 2, etc. Letters are scored regardless of the case. All right, so now we need the newspaper titles. So we kind of already did that over here on bonus 2 tabs. So we didn't get the titles because we got a different cell, but we have most of the structure here. So let's pull it over. All right, we don't want B2, I think at B8, I think we want B2. Yep, there's where all our numbers are. And now we need to take these, all uppercase letters that we see, and turn them into characters. Before we do that, though, we do want to filter out anything that's not a letter. So let's go ahead and do that. All right, so to do this, I'm going to advocate for something that's not allowed in competition, but is a nice handy thing to do in just your day-to-day workflow. And that's going to ChatGPT or some other AI and asking for a nice solution to this. And so what I just pulled and put in my formula here, and let's actually clean up the formula it gave me just a little bit. I just prompted it to give me a formula that will remove non-numeric letters from a string. All right, and we can see it's not referencing the right cell for me, and that's fine. But here, what is it doing? Well, it's basically doing our mid function trick we have been doing with our letter trick we just did. Basically keeping anything that's a letter and then running a filter at the very end and then joining it back together. So a lot of steps here. You guys can see the formula if you want to work through it. But really my big point here is use AI when it makes sense. You know, for competition, learn it and really understand so you can do it yourself. But really, use it to facilitate your work as best you can. Because now what we can do is we can basically sum up the cars of all of these, right? And if you know that car of A, code of A, I get these mixed up sometimes, and put it in parentheses is 65, right? Then we can take the codes of all these letters together, and then we can subtract 64 from them. That way A gives us 1, B gives us 2, etc. So we're going to do our mid of the text, sequence length of the text, right? We're splitting everything one at a time. So let's start with that. But then we want the code of each one, minus 64. And then I want to sum that all up. So you can see the steps as I'm building this. I get my sum that I can then copy down for all of them. And this is the one I wanted the max on my bonus, not the sum. So let's get the max of all those, 233. Get to our last bonus, and we got it. And the last thing I'll say is my shortcut I used there was actually a paste special, Alt-ES, and then L to paste a link. So you can see it's linking over to bonus 2. That way I can find where my answer was later on rather than just pasting the values, which makes model audit very tough in the future. All right, I hope you learned a lot from watching this Sudoku walkthrough. I hope you're inspired to try it yourself and also build your skills up so you're ready to compete for next year's MECC championships. See you there.